This is Mr. Halsey for H2 Sufficiently Understood Science, and today we're going to be taking a look at atomic structure. So let's discuss matter. Matter is anything that takes up space. It's made up of tiny particles of atoms. So you are made up of atoms, you are made up of matter. The rocks, the trees, everything's made up of this matter. And so atoms are the smallest complete part of matter. So what does that mean when we use this word complete to give us a full understanding? That means that there are smaller partial parts that come together to form atoms. And that's what we're going to be looking at today. So inside of an atom is the nucleus, which is the center of an atom containing the protons and neutrons. These will always be at the center of an atom. They'll always be at the center. So let's take a look at these two individual parts. So protons are located inside the nucleus, right here, and they have a positive electrical charge. They have a positive electrical charge and a mass of 1 AMU. So AMU stands for atomic mass unit. And so whenever we get into the periodic table, this idea of atomic mass is very important. So we're going to take a look at that. Neutrons are located inside the nucleus as well, and they have a neutral electrical charge. And so when we talk about this word neutral, essentially what we mean is it doesn't have an electrical charge. It's not positive, it's not negative. Now its mass is also 1 AMU, atomic mass unit. Now electrons are located outside the nucleus in an area we call the electron shells or the electron clouds. And these are little orbitals surrounding the nucleus. And so they actually revolve around the nucleus. Now here there's a bit of a misconception when it comes to electrons. So if we're looking at this, we see basically a circle, looks a lot like a proton, but that's not what an electron is. An electron is not physically there. So to explain this, electrons are more or less electrical waves the negatively charged electrical waves that go around the nucleus of an atom. And this actually makes sense why they're going around. Let's think about a battery, right? So any AA, AAA battery that you get is going to have two things. It's going to have a positive side and a negative side. And so when it comes to the structure of an atom, basically you're going to have the same number of electrons as you will protons, because you always have the positive and negative. So to be a stable atom, you're going to have the same number of electrons as you would protons. There are some cases where you don't have the same number of electrons as you do protons, but that's not a stable atom. This is known as ionization. And so these have either a positive or negative charge depending on if it's gained an electron or lost an electron. And you only gain or lose an electron, you don't gain a proton, because when it comes to protons, protons are what determine what an element is. If I have one proton, I have hydrogen. If I have two protons, I have helium. So I can't gain a proton and still be hydrogen. So you only gain and lose electrons in ionization. Now, because these are waves, like I previously stated, that because electrons are waves, their mass is less than 1 AMU, well, less than 1 atomic mass unit. And when we're saying less than, basically non-existent as far as mass. They're basically just energy. And so when we're talking about periodic table, you may see an atomic mass on some things like 1.011. You may think that that 011 is the electrons, but it's not. That mass number is actually made up after they've taken numerous numbers of atoms of that type, and it's the average mass of that element. Now, electrons do hold a very significant purpose when it comes to the formation of complex matter. So atoms are the basic unit of matter, but they have to combine in order to form larger matter. So like H2O. And that's a process called bonding. Now, the electrons, more specifically the valence electrons, are the ones that are going to facilitate this bonding. And so these valence electrons are the number of electrons in the outermost shell of an atom. So this is actually the same number, you have the same number of valence electrons as you do the group number on the periodic table. And so there's a little trick to this that we'll go through, but let's say, for example, I'm looking at group number 13, okay? Well, if I'm at group 1, I have 1 valence electron. If I'm group 13, that doesn't mean I have 13 valence electrons. What you do is you cover up the 1 in that group, you have 3 valence electrons. And the reason for that is that valence electrons typically on the outermost shell, when it comes to these atoms, most of the time you'll only have 8 as a maximum, and 8 makes them happy. So these different valence electron shells, these different shells can hold different numbers of electrons. And so they are used for bonding. And if, let's say, the outer group has 7 valence electrons, in order to be really happy, it wants to have 8. So it's going to seek out another element or another atom that has a valence electron available for them to share. And that's the key word there, sharing of valence electrons. They don't take valence electrons. In a way, you can kind of think about it like this. Let's say we have hydrogen, easiest one to explain, because hydrogen has 1 valence electron. And in order to be happy, because it's right here, it only has 1 shell, it wants to have 2. Now, so for hydrogen to be happy, it wants to have 2. So it'll seek out another element. Let's say in this case, it seeks out another hydrogen with 1 valence electron. And so essentially, the electron waves will go in a figure 8 around both elements. And that's what bonding is. They're sharing that electron. So each shell can hold a different number of valence electrons. The first shell can only hold 2. The second shell can hold 8. The third shell can hold 18. And the fourth shell can hold 32. However, there is a little bit of difference between different elements. Specifically, this is the valence electron configuration that works with transition metals, the ones in the middle. But most of the other atoms, outside so all the other groups, are going to use a different valence electron configuration, 2, 8, 8, 18. So there are two different valence electron configurations. The one we'll deal with in 8th grade is the 2-8-8-18. And this will come in handy remembering this whenever we're talking about Bohr models. So a very simple little acronym to help you remember the different parts of the atomic structure is PIN. Protons, electrons, neutrons. So these are the three parts that make up an atom, also known as subatomic particles, because they're smaller than an atom. They build an atom. And that's all we have for you today. Remember to like, share, and subscribe. And this is Mr. Holsey signing out.